Two-slit interference in transparent liquid. Suppose you illuminate two thin slits by monochromatic coherent light in air and find that they produce their first interference minima at plus or minus 35.2 degrees on either side of the central bright spot. You then immerse these slits in a transparent liquid and illuminate them with the same light. Now you find that the first minima occur at plus or minus 19.46 degrees instead. What is the index of refraction of this liquid? Now, where do we get the first minimum? The first minimum in Young's double slit experiment corresponds to a path difference delta, which is d sine theta. Now, if it's in air, d sine theta air will be equal to lambda over 2 in air. Okay, so we find that sine theta air will be lambda in air divided by 2d. Now, if this experiment is performed in a liquid, it's going to be d sine theta in the liquid. That's lambda divided by n divided by 2. So it will be lambda divided by 2n because the wavelength of light decreases inside the liquid from lambda to lambda over n. So this is in the liquid, and therefore we find that sine theta liquid for the first minimum will be equal to lambda divided by 2nd. So if we take the ratio sine theta air to sine theta liquid, this will be equal to n. So we can determine n by looking at the ratio of sine theta in the two cases. So we can calculate n then to be sine of 35.2 degrees, that's in air, divided by sine of 19.46 degrees, that's in the liquid, and this gives us an index of refraction of 1.73. Okay, so we're performing Young's double slit experiment in air first. We find the first minima occur at 35.2 degrees on either side of the central bright spot. So this angular displacement will have the path difference d sine theta air equals lambda over 2 in air. When we put the apparatus into the liquid, the wavelength of light decreases from lambda to lambda over n. So d sine theta L becomes lambda over 2n, which is lambda in the liquid divided by 2. So lambda over n is lambda sub n. Lambda over n is the wavelength in the liquid. So if we take the ratio of these sine theta air to sine theta liquid, we find n. So we just take sine of 35.20 divided by sine of 19.46, which gives us, for the index of refraction of the liquid, 1.73.